Hello. In this video, we'll be showcasing our work on learning control from expert demonstrations by applying the methods we developed on the case study of quadrilateral control. First, we choose an expert controller and use it in simulation to collect demonstrations of it, stabilizing the quadrilateral at the origin. Each of the videos on the grid represents how the expert controller stabilizes the quadrilateral from various initial positions, velocities, and accelerations. Note that we only use 9 demonstrations to learn control. Next, we apply both the learned controller and the expert controller to the task of following a slanted figure of 8 in the air. Please note that this is completely different from the task that we have asked during the expert data collection. The learned controller tracks the trajectory well, with the error that is of the order of centimeters. However, in comparison to the expert controller, the learned controller takes a longer time to settle. This phenomenon is especially noticeable in the experiments where the initial position of the quadrilateral does not match that of the reference. We note that the controllers have comparable errors, with the small exception that the learned controller tracks the reference better in x and y, but worse in z. We use the last portion of the experiment to compare set point stabilization of both controllers. Both controllers quickly reach stability, but exhibit a steady-state error in x and y. We attribute this error to the fact that we compute the control inputs externally, and there is a delay in sending them to the quadrilateral. Overall, we believe that the performances of the expert controller and the learned controller to this arbitrary task are sufficiently close to each other, notwithstanding the fact that the learned controller was trained using data from a completely different task. Thank you for your attention. If you are interested in more details about this project, you can find the preprint of the paper at our website, and the code for both the experiments and simulations at our GitHub repository.